Suppose you're asked to find the number of trailing zeros in some massive factorial number like 1000 factorial. Now, what this question is asking is if you evaluate 1000 factorial, so 1000 times 1000 minus 1, so 999 times 998 times all the numbers until 1, how many zeros does this have? Number of zeros. Now, we are never going to do this by hand. Normally, just by multiplying, right? And even if you had a calculator too, you'd probably get some just massive number, which the calculator wouldn't even list all the digits of right away, and you have to like count them out in your head or count parts of the factorial. I don't even know. How we solve this is a useful trick I learned called the rule of 5. Now, what the rule of 5 tells us is we can find the number of trailing zeros in a big factorial number like this by dividing the number, so not 1000 factorial, but dividing 1000 by all the different squares of 5 and finding the next lowest positive integer under those quotients. Now, I just said a lot of stuff, but let me actually visually explain it. So given 1000 factorial, we can say that the number of zeros is 1000 divided by 5 to the 1 plus 1000 divided by 5 to the 2 plus 1000 divided by 5 to the 3. And now when do we stop? You already get the pattern, but when do we stop? Well, we stop right there at 4, and I'll explain why. We stop at 5 to the 4 because we want to stop when 5 to a certain square is above our number. So 5 to the 4 is only 625, but 5 to the 5 is, let me think, 3125, which is our above 1000. So we don't want that, and we stop before that. And now why this is important is another step that I sort of withheld for now, and is that we don't only take these quotients, we take the next lowest positive integer under each of these quotients. These brackets I'm putting around aren't just normal brackets. What this means, next lowest positive integer. To sort of visually explain what that means is that, let's say we have the number 10 divided by 3. Now obviously this doesn't really divide well. It would be 3.3 factorial, which is our 10 on 3. But if we evaluate with these brackets and find the next lowest positive integer, instead of our 3 factorial, it would just be 3. So it's nice clean numbers is really what it makes it. And so in our case, we can evaluate this to get 1000 minus 5, so 200. 1000 minus 25, so 40. 1000 minus 125, so 8. And as we saw, this is 625, so it'll only be 1, because we're finding the next lowest positive integer. And this makes 249. So the number of zeros in our 1000 factorial is 249. And we did that using the rule of 5. So just to recap, we take our factorial, we find all the quotients of the squares of 5, in which we take the next lowest positive integer using these brackets that I showed, and sum up all the quotients. And we only divide by 5 to a certain square as long as it's below our number n. And again, we're not dividing by 1000 factorial, we're dividing by only 1000. So that was a neat trick I learned, the rule of 5.